Bismillah ar-Rahman ar-Rahim. So we started chapter 4, user authentication and key distribution. We talked about symmetric key distribution using Kerberos framework. We talked about the details, the protocol, and the message formats. So today, inshallah, we are going to start key distribution using asymmetric encryption. Of course, one of the major roles of public key encryption is to address the problem of key distribution. Of course, some of the public encryption protocols like RSA are general purpose. They can be used for key distribution as well as for encryption and decryption and for message authentication. But they also can be used for key distribution. Another technique for that is, as we said before, Diffie-Hellman. So for all these techniques, they use public as well as private keys. So there are two distinct aspects to use the public key encryption. First, the distribution of the public keys themselves. The question now is that just the fact that the public key needs to be communicated to everyone. Does that mean that we should accept any public key that we receive from anyone? Is that the case? So any public key that we receive from any entity, so we should just put it in the key chain and we start to use it? Of course not. So we need to have trust in any public key that we receive, and or in other words, we need to have some authentication or message authentication built into that public key. The use of public key encryption can also be used to distribute secret keys, asymmetric keys. So that's straightforward. But again, the question remains, should we actually accept any public key that we receive from anyone? Of course not. And therefore, we have to really use a special format to exchange the public keys with all the outside world. And the standard that's used to do that is the public key certificates. So we all heard about certificates. So certificates are the best and the authenticated way to communicate public keys to anyone. So public key certificates, they consist of public key plus the user ID. So there is some user identification, of course, and the public key. And within the whole block, it's signed by a trusted authority. So this is the key thing, is that any certificate, it actually contains the public key of the user and the user ID, of course. So this identification is okay, but it has to be signed from a trusted authority so that we can trust it and we can say that, okay, so this public key I can in fact use that to communicate with that user ID or to communicate with that user, right? Type. So now the question bardu comes back. So if I don't trust that user, why do I have to trust the third party or the one that signed this certificate? The question is easy. You have to trust someone, okay? Like for us, we have all our money in the bank, which means that we trust the bank, right? So at the end of the day, we trust the bank. So at the end of the day, you have to trust someone, okay? So we trust, like for example, Microsoft being the certificate authority for all the Windows services and so on. So at the end, trust is implicitly there for certain entities. But when it comes to public users, the level of trust is not similar compared to trusting an official entity, right? So typically, the third party is a certificate authority. So we call that a certificate authority. Okay, certificate authority is an entity that owns, certain organization, and we can, provide some level of trust to that organization. So therefore, they can sign these certificates that contains the public key for the users. So these certificate authorities, either like big vendors like Microsoft, like Apple, and so on and so forth, and or the governmental organizations and so on, like banks. And so a user can present his or her public key to the authority in a secure manner and obtain a certificate. So any user who wants to communicate his or her public key, they have to present their identity, okay, to that certificate authority, and then the certificate authority would they will have the overhead of authenticating that person and giving that person a certificate that really contains their identity as well as the signature of the certificate authority. So only then we can trust this certificate and use that public key for that user. The user can then publish the certificate. So these certificates are just plain text files. So once it's signed, it's a plain text file. You can store it on a server. You can send it, over the internet to anyone as plain text. There's no need to encrypt it or anything because it's signed with the certificate authority. Okay. So the part about the public key itself is a plain text. Okay. There's nothing hidden about it. What's really hidden is the signed part, and the signature. Okay, is actually signed by the certificate authority is a private key. Okay. So anyone needing the user public key can then obtain the certificate and verify that it's valid by the way of attached the trusted signature. But in order for us to be able to use that public key in the certificate, the first thing we do is that we verify the signature of the certificate authority. Okay. If we can verify the signature of the certificate authority, then we trust that this public key is coming from an authorized entity, and we can use that public key from now on. So that's what typically happens whenever we connect on any website, whenever we click on certain links. Of course, that whole thing happens in the back scene. You don't even have to do it manually in any way. Okay? So that's the process. This is the system model for this public key certificate use. This is the certificate. The certificate is composed of the Bob's ID information, the identity of Bob, and Bob's public key. Okay. Then the certificate authority information, and that's also a plain text because we need to know what certificate authority has actually signed that certificate. And then this is the part that's really hidden, and it's actually encrypted with the private key of that certificate authority, right? So it's nothing but the hash for this part, for all these parts of the message. These parts of the message will be hashed. We generate a message digest, and then this message digest will be encrypted using the certificate authority's private key, right? The certificate authority's private key corresponds to the public key, which is already, so we know from the identity of that certificate authority, we have the public key for that certificate authority if we want to verify any certificate that's signed by this certificate authority. Okay. So on the other side, or at the receiver side, what we need to do is that the first thing we get this, we hash it using the same algorithm, and that's why we will see in the certificate the hashing algorithm has to be the hashing algorithm information has to be also embedded into that certificate. We'll see that in a minute, and then we hash it, and then we decrypt this signature using the certificate authority's public key, and then we do the match. Okay, we do the match for the two hash. If we find them identical, then we accept, and then we start to use the public key for Bob. Okay? Anything that's not clear here? This is very systematic. This file, as we said, it can be stored on the server, plain text, can be communicated to anyone. There's nothing hidden about it. Okay? So ITUT, as a standard organization, they came up with like a portfolio of standards, actually, which is the X500 series. The X500 series is not just one document or one standard specifications. They actually represent a series or a group of standards. One of them is the 509, which standardizes what we call directory services. And these directory services, they have all the specifications for how to use these certificates, how to store them on the server, how to authenticate users using these types of certificates, and so on and so forth. Okay. So the directory may serve as a repository for the public key certificates. As we said, these certificates will be stored on a repository on any server, and as you can consume, as the user consumes some of these certificates, they get also cached in different clients. So for example, if I use the certificate of Bob, I will get the certificate communicated to me through the certificate authority. You will see that. And then I verify. Once I verify, now I can use Bob's public key, which is currently cached in my memory. So by doing this process, I cache many public keys and many certificates in the local machine, and they can also be cached on any directory server, as a group of certificates, and I can use any of these certificates, verify the identity, and so on and so forth. Okay. So. This standard was issued in 1988. Not that we care about the date. And there is in this standard we actually define multiple versions of the certificate format. So we'll see the differences, the slight differences between the versions, and why we came up with these new upgrades and new formats of these certificates as the standards actually evolved. Okay. The standard does not dictate the use of specific algorithm for encrypting the signature, right? So you can use RSA, and you can use any other, public cryptography technique for signing the signature of the certificate authority. So this is the format of the certificate. So as we can see, there is the version. The first thing is the version. And the version, of course, here we have multiple versions. So version 1, for example, ended here with the basic parts of the certificate, or containing the identity of the user, the public key of the user, and the information of the certificate authority. Not more than that. So these are the basic components. So in version 2, they started to have what we call issuer unique identifier and subject unique identifier. And we'll talk about the reason for this. Why do we need to have issuer unique identifier and subject unique identifier? In version 3, we use the concept of extensions. Okay, so the extensions came as an upgrade in version 3, and we'll talk also about why do we need to have extensions and what they mean. Okay, but the basic stuff, which is in all versions starting from version 1, is actually the version, also the certificate serial number. The certificate serial number is an identification for that certificate, and this is to be used later on if we store this certificate file on a server, communicate it, things like that. We'll see why we need that serial number and how we can revoke it at a certain point, or provide some extensions, limitations on this certificate. We always refer to the certificate with the serial number as an identifier for this certificate to do anything. So this part is not actually it's actually redundant, because it's actually mentioned here again as part of the standard. So the issuer name is actually the person's name. Okay, so the issuer was the one who issued or initiated the creation of this certificate, is the actual user. Okay, the user who initiates the creation of this certificate with the certificate authority. Or sorry, this is the issuer. Sorry, the issuer name is the name of the certificate authority. The subject name is the name of the user. Okay, the subject name is the name of the user. And here the period of validity. This is very important, and we'll see why the period of validity here refers to the validity of that certificate. So it's very important to know that this certificate is valid only within a duration of timestamps. So this certificate is not to be valid before that date, and it's not to be valid after that date or timestamp. Okay. So if for example I fetch a certificate file from the directory server and then I compare the current time with the time before or after, and I see that it's outside this range, this means that this certificate is not valid. I should not be using it. Okay? Because the certificate authority only signed this certificate to be valid only within that time. So why do we have this? Because, of course, the public key can be renewed, can be revoked, it can be anything. So we always have to check the validity of any certificate before we can use it. So this is the subject's public key, and as we said before, this is plain text. We don't have to hide anything. So the algorithm is the algorithm that created that public key. Could be RSA, could be Diffie-Hellman. So parameters here is the parameters that could be used by the algorithm. Like, for example, if you remember, we talked about Diffie-Hellman. We said that for Diffie-Hellman, we have to use two parameters. حد فاكرهم اللي هم ايه؟ Alpha and Q. برافو عليك. So we have alpha and Q, and these are to be shared publicly. Okay? So any two communicating parties, the alpha and Q, they can be, unlike RSA, of course, if you remember, the P and Q, okay, these are private. These are not to be exchanged. So these parameters are optional, and you can fill them with whatever parameters that you want to be used as part of this algorithm. So if you communicate, for example, alpha and Q as part of a Diffie-Hellman or something, then we can use that to run Diffie-Hellman algorithm. And this is the public key. This is the actual public key as plain text. There is nothing encrypted about it. So these are the basic parts, and of course with the signature. So this was part of version 1. Version 2 added issuer unique identifier and subject unique identifier. Why is that? Because as live evolves, we get more complexity, right? And so any certificate authority and any actually user, you could have multiple public keys and multiple private keys, of course. So similarly, the certificate authority might have multiple public keys that each of them to be used in specific service or within a specific domain, right? So, for example, the Microsoft Certificate Authority server, which is it's running as part of the operating system or something, it can in fact have multiple public keys, for different services, right? So this unique identifier refers to which of these public keys are being used as part of this certificate. So using that unique identifier, I can identify which public key for that certificate authority that I can use to verify the signature and so on. Okay? طيب, this is again for the user as well as for the certificate authority. So now the extensions came as part of version 3. Okay, and again, this is part of of the complexity, of the added complexity. So again, when we started to use these public keys widespread through the internet, there are some limitations and some restrictions that we need to put on this certificate. For example, some certificates are to be used only for مثلا email services, but we cannot use it for banking services, for example. Okay, some certificates can be used within a specific domain, a private domain, but they cannot be used in public domains. So I may actually use these certificates to specify a range of IP addresses, for example, or names for some services that this certificate is only valid for. Okay, that's not, this is different from before and after. Before and after only works on the timestamp or the date. But there are more than that. There are more restrictions than just before and after. there's specific service, specific domain, specific range of IP addresses, okay, where this certificate is only valid for. So this is when the extensions can come and provide these limitations or restrictions based on which we can use these certificates. Okay. Okay. So the user certificates generated by the certificate authority have these characteristics. The certificate authority's public key can verify the user's public key. That's normal. So we need to have the public key for the certificate authority. We decrypt the signed part, and then we get the hash, and then we can compare the hash, as we said before. Certificates are unforgeable. Unforgeable معناها إيه؟ Any part of the certificate that gets manipulated, what will happen? Hash change, which means it becomes invalid right away, right? So in that case, it's similar to, if you remember, to tickets. Similarly, you can have it, but you cannot manipulate it in any way. If you manipulate it in any way, even if you add one single character, it becomes invalid. Okay. If all users subscribe to the same certificate authority, there is a common trust of that certificate authority. So if we have the certificate authority and we all trust, like for example the bank, okay, I can connect to the bank, I can trust it, and if I want to transfer money to another person in the same bank, it's easy. We both trust the bank, and the bank will facilitate and mediate the transfer or any kind of interaction between the users. That's normal because both of us trust the bank. So all user certificates can be placed on the directory server of that certificate authority or any other server because they are plain text files. Or in addition, a user can transmit his or her certificate to other users over the internet. They are normal files. The problem now is that as you can imagine, if users, they trust the same entity, they can, communicate with each other normally. But what happens if I want to transfer the money to another person who has accounts in another bank? Then I trust my bank, he trusts his bank, okay? So there has to be some mutual trust between the banks as well. Or in other words, you can never imagine having one certificate authority to cover the entire internet. That's not scalable, right? So as we can imagine, we also have the ability of having multiple certificate authorities. But this would require the fact that these certificate authorities, they need to trust each other. They need to have like some mutual trust between each other. And even that trust sometimes might be through some third party. So Microsoft can actually trust Apple indirectly through Ministry of IT in the US, something like that, okay? So sometimes the certificate authority, they can trust each other through some third party, which means that the trust relationship is kind of recursive, okay? That's what this tries to say. And as we can imagine, the internet as a very scalable and big architecture, it requires the existence and the interaction between multiple certificate authorities through like some mutual trust, okay? So in other words, this provides the framework of centralized trust or distributed trust as well. But the distribution here is kind of limited because we all trust the certificate authority, and the certificate authorities, they can trust each other, right? But users, they go directly to certificate authority. Of course, now we came into the revolution of, peer-to-peer trust through what? Blockchain. Through a? Blockchain, bravo Ali. Yeah. So this is that's why when this concept came about, it was disruptive, right? Because we don't need any certificate authority. We don't need any centralized entity to kind of provide trust between each other. عشان كده maybe I disagree with that name, but always when they refer to blockchain, they say zero trust framework for whatever. Okay, zero trust. We don't require any trust or any trusted authority to kind of, interact together. So we will use the power of the crowd, in a way, to facilitate that trust. That's what, blockchain relies on. It uses the power of the crowd, okay, to facilitate that trust. And that's why this concept, when it first came to the picture, it was very disruptive, okay? Type. With many users, it may be more practical for there be a number of certificate authorities, and now it becomes the issue of how these certificate authorities can interact with each other. That's what we need to talk about. So consider a scenario that user A obtains A's certificate from certificate authority X1. So we have a relationship. So we have node A, and A trusts X1. And we have B, and B trusts X2, okay? Similar to the scenario that we just talked about, I want to transfer money to a person on another bank, okay? So this is bank X1 and bank X2, and we need to transfer across them, all right? So as we said before, so we have to have some kind of a trust between these two. So in order for A to communicate with B, A has to start from what it trusts, okay? And from X1, it goes to X2. So from X1, it can verify the signature, or it can verify the validity of X2, okay? Once it verifies the validity of X2, then it can use X2 to verify the validity of B, okay? So we call this chained certificate. Okay, so this is chained certificate. So we have to do that on 2 steps for this simple scenario. So we have to do that on 2 steps. But remember, يعني X1 and X2, they can have, this requires the fact that they can have mutual trust. But this mutual trust sometimes is validated through another X3. Okay? So in that case, we have to go this way and then this way, something like that. We have to start from whatever entity we trust, and then we can go from there. Okay? So we can use the concept of chain certificate to do multiple steps until we verify the validity of B or any entity that we want to communicate with. Okay? So the idea is that why we stop at X1 or X2, so we could have X3, we could have, so the implication is that here we have, in fact, a tree, or in general, a graph that represents the trust, the mutual trust between these entities. So we have like terminal nodes, like A, B, C. These are terminal nodes, and all of these are certificate authorities, and they have some mutual trust between them. What I noticed, like, there is some missing part here. So in the book, they try to show a tree, but in general, actually, it's a graph. And as you can see here, there is XZ, and here there's ZX, which means that there is direct relationship between X and Z, right? And that's the general format or the general representation of this mutual trust on the internet. It could be a tree or a graph in general, okay? So now we have some definitions that we need to talk about. So when I go this way, this way, we call this reverse certificate. Okay? If I go this way, or if I use a certificate to traverse the tree this way, then this is a forward certificate. Okay? So a certificate like WV, that's a WV, it's a reverse certificate, right? But VW here is a forward certificate. Okay. Also V here, V it's called root certificate authority. Why? Because it has multiple branches of trust relationship with other certificate authorities. واضح كده؟
Is X a root certificate authority as well?
لا, X is connected, usually no, X is connected with terminal nodes. So if you have the trust relationship with other certificate authorities in multiple branches, that's when you can call it a root certificate authority. Root certificate authority provides the trust relationship to other certificate authorities.
Can we have like multiple certificate authorities?
Well, that's the case. All of these are certificate authorities with the only exception of A, B, and C.
Roots, can we have multiple?
Oh, yes, because as we said, in general, it's a graph. It's a graph. So any node that has multiple branches that connects multiple certificate authorities is considered the root certificate authority. Root certificate authority. Okay? So these are just clear definitions. So if I want to, for example, communicate between C and B, because C and A is obvious. C and A is خلاص, it's one certificate would be enough. So if I have the mutual trust between X and Z, then now C has two ways of verifying B. So C can always start from X because that's what it trusts, and from X it can verify Z, and then from Z it can verify B directly. So we call this cross certificate because it's in the same level. So if you go cross, then this is a shortcut per se. But the other alternative is from X, we can use the reverse certificate to verify W, and then from W we verify V, and then from V all the way to B. So we have to go this way and then this way. It's a longer route, but you know, if that's what you have to do, then you can do that. I have to also mention here that just the fact that we have this graph representation doesn't mean that these certificates are actually stored in a form of, they are stored on the directory server as files, right? And they are to be cached. And also remember here that that doesn't necessarily happen with every click that you do on the internet. Because C currently has direct trust with X, okay? But after a few clicks, you may have actually direct trust with Y. So you can start from Y, right? So I don't have to do all these verification for every single click because all of these are cached, and I can just do this verification with the workflow, and once I click, I can now have trust with V, I can have trust with U, I can have trust with Y, and for every single click, I start from wherever I trust, and then I go forward. واضحة دي ولا؟ واضح؟ So this is just يعني not to imagine that you have very, very long paths and you do this. So this means that with every single click, I may have to do like 10 different verifications or 12 different verifications. All these verifications are done incrementally, and they are to be cached. And you always start with, whatever you trust, and then you increment the trust as you move through the workflow.
Are they called the one in the middle, the intermediate certificates? Or is it
What? ما فيش intermediate certificates. يعني هو في these are the concepts that we that at least it's commonly explained. There is the concept of forward certificate, reverse certificate, cross certificate. There is the concept of root certificate authority. These are the common terminology when it comes to dealing with certificates. Okay. Any other questions? So these are the ways to deal with certificates to verify the user's public key. There is the concept of revocation. Revocation is very important concept here. Because these certificates, they are stored. You can never imagine that, we have the before and after, the validity period, right? But there are certain events that might happen. Like, for example, Bob, is now working in Apple, and all of a sudden he left and he works now with Microsoft, okay? So you can imagine that Bob's public key in Apple should be revoked, right? Should not be valid. Otherwise, he can use that, to do certain harm. Yeah. So there are certain events that might happen that makes the certificate invalid, other than just the period of validity, right? But how can we do this? Because this is event-driven. This is event-based, right? We don't know when Bob will leave, a certain organization, right? So typically, a new certificate is issued just before the expiration of old one. Sometimes that scenario also causes the duplicate certificate, right? So one certificate has to be revoked. It happens very commonly that before the period of validity finishes, right, we have to generate another certificate just to facilitate the continuous communication. But now there is some overlap, right? So in some cases, we always have to resort to revocation of the old certificate before we can use the new certificate. So the concept of revocation happens very regularly. And that's why in the standard, they define the concept of revocation being sent regularly, like almost every day. So a certificate authority, they generate a list of certificates that are currently revoked. These are certificates that are very close to being expired, or certificates that the owner of that certificate, he left the organization and now he works elsewhere and we have to revoke or a certificate authority that has certain level of compromise. A user has been compromised, or a certificate authority has been compromised. So if a certificate authority has been compromised, any certificate that has been signed by this certificate authority have to be revoked right away, right? So these events might cause the regular revocation of these certificates. So in many ways, it's desirable on occasion to revoke a certificate. Revoking a certificate means that this certificate will, all of a sudden, they will become invalid, which means that they have to be removed from the directory server, and we have to so before we use any certificate, we have to make sure that it's not in the revocation list, okay? So for example, a user's private key has been compromised, the certificate authority's private key has been compromised, or a person has left the organization. So these are the reasons. So the CA is assumed to be compromised. So all of these are scenarios or events that might cause the revocation of certain certificates. So in this standard as well, they define the concept of revocation list. So the certificate revocation list, or CRL, it maintains all the lists of certificates that should be revoked, and they contain like two pieces of information. So it's issued by the certificate authority to the users, and it's also issued by, it's like once the certificate authority creates that revocation list, it should actually traverse it through the graph that we talked about. It should send it to all the entities and all the other certificate authorities that it has some mutual trust with, and also to the users in the current organization. So these are the fields in that revocation list. So we have only the issuer's name, which is the name of the certificate authority that issued that revocation list, and we have the list creation date. We'll talk about why we need to have the date, the exact date when this revocation list has been created, and the next command, the next certificate revocation list date. So why do we need to have that? So and also the list of entities, the list of the certificates is identified by what? by the certificate serial number. So we have the serial number and the revocation date. So the format of that revocation list. Okay. So we also have the revocation list of also is signed by the certificate authority, as we can imagine, because again it applies to the revocation list that when we receive a revocation list, we have to verify the certificate authority that issued this verification list. And we have طبعا the algorithm, which is like usually this is the SHA, which is the hashing technique that is used to create the hash of that, right? And there is the issuer name, update date, and next update date. And the reason for this is that, when you try to fetch a revocation list and you check the current date and you see that the current date is in fact after this date, what does that tell you? This is the next update date. If you fetch a revocation list, and then, because we said that these revocation lists, similar to the certificates, they are stored on the directory server, right? So if you fetch one of these lists and then you say the current date after this next update date, and the answer is yes, what does that tell you? This tells you that the revocation list is old and you need to fetch a new one, right? So you need to go and fetch a new one, okay, which has the update. So the date has to always be between the update date and the next update date. That's when you know that this revocation list is fresh, okay, and you can in fact use it. It's similar to the before and after for the validity of the certificate. واضح كده؟ So this is the serial number of the certificate and the revocation date. And of course, as you can imagine, the revocation date doesn't have to be the same for all of them, because you have like some event that it will start after, like Bob will leave the organization on this date, things like that. So it depends on the event. You can specify the date after which this certificate is to be invalidated, and of course this date is usually before the end date of the certificate. So I have to end prematurely that certificate, even though it's not expired, but I have to revoke it for the events that we talked about. ماشي؟ واضح كده؟ طيب. Certificate extensions. So we need to talk about extensions now. As we said, extensions are to be used to provide more restrictions on that certificate. Restrictions like, for example, this is only valid for a private domain or a range of IP addresses, or a specific type of service, like مثلا non-banking services or email services or something like that. That has nothing to do with the period of validity, before and after, because this is part of the certificate anyway. But this is like some extra restrictions that we need to apply to this certificate. And of course, as we said before, this always comes with the increased complexity that we have on the internet, every now and then. A certificate policy is named a set of rules that indicate the applicability of that certificate. So this certificate is applicable only for a specific range of IP address or a specific domain, and so on. So, for example, a policy might be applicable to the authentication or electronic data exchange. So this is a specific type of service. It's only available or only valid for a specific type of service, EDI. Okay? Transactions for a trading of goods within a given. So it could be valid only for communication with a specific website or a specific domain, and so on. Okay? Okay, any questions with that? So this is the key distribution for using asymmetric encryption. So the last part in this chapter is the identity management. Okay? So we can have 10-minute break and then. Okay. Another part of this standard series, اللي هي X500, is the identity management. So for identity management, we need to manage the identity of the users and manage all the privileges and so on and so forth. So there are certain concepts related to that which we need to discuss. So if somebody works in IT, you know what LDAP is. So LDAP is like a centralized identity management, which can be used to facilitate the concept of single sign-on and these kind of things. So usually we use that within organizations to provide centralized identity management service that, you know, users can provide their credentials, they can claim certain identity, and they are given certain role, whether like a system admin or a faculty member or a student or a finance officer or things like that. And based on that, they have certain, you know, access privileges, yani, to certain parts of the system, but not the others, and so on and so forth. So that's managed through the identity management system. So it's a centralized and automated approach to provide enterprise-wide access to resources. So based on your identity and based on your claimed identity, you have certain level of access to the different resources. Focus is defining an identity for each user, whether it's a human or a device or a process. So even a device can authenticate itself to the identity management system, not just or a process or something like this. We'll talk about this in the next chapter, talking about the network access control security. Talk about this. The user, in addition to the identity of the user might have certain attributes, and these attributes include the role. Okay, so based on your identity, you have certain attributes. These attributes could be your role in the organization, could be like credit card information, could be like some other, you know, support, documentation that kind of, you know, give you certain level of privileges. For example, I'm a faculty member. How can I claim my role as a faculty member? Probably it's more rigorous. It's more rigorous compared to any other employee in the university here. So I have to provide, like, for example, some attested, transcript of my PhD that comes directly from, my institution that I graduated from, and in addition to some other support document. And based on all of these attributes, I am now given the role of a faculty member. So you, as a student, you have to provide similar things. And these are to be stored with your identity as attributes. Okay? So it's the identity management is actually a central concept. The central concept is the use of single sign-on. So this single sign-on, you provide your credentials to the system, and based on that, we verify your identity. Okay, and this identity is to be used or shared across all the services within that organization. So, for example, I can verify your identity once, and then you are able to now use MyQU, you are able to use Blackboard, you are able to use any services within the department or within the organization, within QU. Okay? Similarly, if you provide your credentials, for example, in Google services, so once you log on to مثلا Gmail, it's like one log on that gives you access to all the Google services. So when you switch from one service to another, it uses the same credentials and the same identity across all the services. Okay. So of course there is also the concept of federation, which we will talk about. So not only our identity is shared within this all the services within the same organization, it can in fact be shared to other organizations based on certain agreements. Okay, this is the concept of identity federation. We should talk about this in a minute. So the principal elements of the identity management system is composed of all these definitions. There is the concept of authentication using the single sign-on concept. I have to also emphasize that there is also the concept of reduced sign-on, and we'll talk about the difference between the two. So single sign-on can be used to authenticate a user who is claiming a certain identity. Okay? Once we log on, we have access to all the services within that organization using one single sign-on. There is the concept of authorization. So based on claiming that identity, the slight difference between authorization and authentication is that by providing a successful authentication, a certain type of authentication, you now successfully get authorized to access certain parts of the system. Okay? So when you sign on to, for example, Blackboard or any service within QU, okay, we now give you the role of student. Okay? So we give you the role of student, which means that we give you authorization to certain parts of the system. Okay? But not other parts which a faculty member has access to. And it's not, and the faculty member does not have access to certain parts that finance officer has access to, or system admin who have access to possibly, multiple levels of service to almost everything. Okay. So this is the difference between authorization and authentication. By authentication, you can get the role of a certain specific role. Based on that, you have a certain level of access to specific part of the system. There is also the concept of accounting. Accounting here talks about logging the access and authorizations. And what that means is that as you continue using the services, we have to log your actions. Why? Because by performing certain actions and some of the services of the university, you may go beyond certain limit that prohibits your access. Like, for example, you have, a quota of like 10 gigs for email services. So I have to log exactly the consumption of your claimed identity to the size of the emails that you consume from the system. Once you go beyond 10 gigs, I have to stop you. Okay? So I have to log every single action that you do within the services that you interact with all the time. So that if you go beyond certain limits, I have to revoke your access, I have to stop your access, I have to do certain actions. Okay? So accounting is kind of related to provisioning. Provisioning is when I say, okay, so I have certain amount of resources in the system, so I will allocate these resources according to certain criteria, whether, for example, if you are a user, then you have 5 gigs of email services. If you are a faculty member, I will give you 10 gigs. So this is based on what? Based on certain pool of resources that we have, and the provisioning process can help you to say, okay, so I will give you a quota of this much, I will give you certain access for a period of time, things like that. Provisioning of resources to the user, or allocating the resources to the different users based on their role. Okay? Type. So that's the provision. Workflow automation specify the sequence of actions of events based on user role. So if you log on to Blackboard as a user, you will see certain workflows which are accessible to you, and you can interact with the system based on your role, and you will see different sequence of actions that you can perform. Okay? So for example, you can get only to certain course that you are currently enrolled in. And you can see the grades for a certain exam that you have done, and so on. So there are sequence of events that you can perform based on your role. If I log on to Blackboard, definitely I have different workflow altogether. I have all the courses that I can teach as a head of department. I have access to all the courses that is currently offered in the department, and I can have access to any course and have access to any instructor. I even have access to different profiles, different HR profiles of all the instructors or all the department members and things like that. Okay? So the workflow is the sequence of events that you can go through, systematic sequence of events that you can go through, and it's very much related to your role. ماشي كده؟ Delegated administration. As you can imagine, if the system is large as QU, for example, you cannot imagine that we have one system admin for all services. So delegated admin here talks about the fact that you have different admins for different, category of services. So for example, for مثلا networks, for the networks at QU, we probably have one or two maybe admin, network admin. So we have network admins, IT admins, we have Blackboard admin, we have, for every service we have a system admin. Okay, so these admins, administrators, they have very, very low level access to everything related to these services. Even they have access to manipulate your role if relevant. Okay. Type password synchronization. That's an interesting concept, because based on what the system provides, you may have what we call single sign-on or reduced sign-on. Okay. For each one, there are pros and cons. For single sign-on, you have, as the name suggests, you have one. You log on once, and you have access to all services within the organization. Okay. Reduced sign-on, you have multiple passwords for different parts of the system. Okay. So what is the pros and cons for each of these? So a single sign-on, I have one credential, one password that gives me access to everything. What is the problem with this?
You get it, it's over.
If this password is compromised, then they have access to everything, right? If someone has his password or her password compromised, خلاص, all the services are gone. Okay, so that's the issue with this single sign-on. So that's why in many organizations sometimes they provide reduced sign-on. So reduced sign-on talks about the fact that you have certain password for category of services, not for all the services. Okay, but that comes with some disadvantages. Bad disadvantages: the overhead of having to worry about renewing these passwords every now and then. So maybe some of you had this issue before, like you get some warnings from the email system that you need to change your password, and all of a sudden you see some of the services are not working properly, and you have to do yes. So sometimes they have to do this to avoid the unified service sign-on, which might have certain issue if any password is compromised. Okay. Also, if you try to access any external service through QU, like for example, Authenticate or Turn-In, or we use as faculty members, we use a service called Digital Measure outside the university for faculty evaluation and to maintain our research profiles and all of this. So all of these are external services that you can access through QU's credentials. In many cases, of course, again, single sign-on does not really propagate to these systems, as difficult as this might be. So we in many cases, if we change our password in QU, even though we are supposed to use the same user ID and password, but if you change your password in QU, it does not get synchronized to all these external entities. Okay? So very commonly, it does not get synchronized. But using this, the concept of single sign-on is supposed to be synchronized. So if the password change does not synchronize to all services, then it's technically reduced sign-on. Okay. There is, of course, the concept of self-service password reset, which in many cases we have to resort to when we try to change our passwords at QU, and then we try to access these external services. It doesn't work anymore. And either you have to remember what's your old password, or you have to go through password reset, and it sends you like some codes through email or on your phone. So you have to go through this hassle every time you have to change your password. So that's why you probably agree with me that whenever we get this notification from QU, it's like, again, we have to do this again. So, but definitely you kind of have to, because every now and then you have to renew your password.
Bank doesn't.
Yeah,
require this.
yeah. Oh, yes, صح, مظبوط.
It's too much.
Yes, but banks, yes,
Yeah.
banks they use OTP, right? Because of this two-factor authentication, and that doesn't mean that banks do not have problems too. So even banks they had issues.
But banking, it's easier than QQ, too restricted for this. I have headache.
So even as so you should be happy, because as students you don't have to do two-factor authentication every time you log on to Blackboard. Like we have to go through all this hassle every time. Like every time we log on to Blackboard, we have to provide 6-digit security code. It's like, come on, my bank requires only 4 digits and you require 6 digits. And even sometimes if we log on, especially from iPads, or it fails and it says you have to communicate to the administrator. I don't even get the code on my phone, or I get the code on my phone, but I cannot enter it anywhere because I have an error. It's a big hassle, yeah. In general, the rule that you learn in life is that security always goes against the convenience of people. If you want to be more secure, it's inconvenient.
That's why I don't like using Apple products.
Yes. Sometimes people prefer some vendors or some services more than the others, because you prefer convenience over security. But for other people, they like to prefer, مثلا, security over convenience. So it's and there is the concept of federation. Concept of federation is a big concept that facilitates the sharing of this identity through vendors or through organizations, and that concept is very important. This is why, like for example, sometimes when you try to sign up on any website, you get the option of using Google account, using Google information. So you click on that, and all of a sudden, the sign up is done, right? Because there is certain agreement between this organization and Google, okay, to have like identity federation between them. So once you click on that option, your identity gets shared from Google system to that website, and that saves you some time, okay? But this concept also can be used to facilitate, for example, a certain role in an organization using some external services. Like I have access to Authenticate. My access in Authenticate is based on my role at QU, right? Because there is certain agreement, okay? So not necessarily that all my information will be shared, but my role can be shared with Authenticate to give me like a normal user access to use Authenticate, okay, through my role at QU. So by logging in to Authenticate using the same user ID and password on QU, okay, you can have normal user access on Authenticate, okay? We'll talk about this. So this is the system model for this identity management, if you will. So that system model here talks about, it starts from the principal or the user or the applicant who has identity being managed by an identity provider. So this identity provider could be like QU, could be like Google systems or something like this. But whether through that identity provider or through an external services such as LDAP or anything, you have also access to some attributes, or you have also associated attributes to your identity. And part of this is actually the role. Part of these attributes, as we said, is the role, which can be manipulated by an administrator. It can be actually manipulated or updated by a system administrator. Okay? So the principal has certain information or identity. He provides his credentials to the identity provider. Based on that, the identity provider can verify your identity, and based on that, it gives you a role from your attributes. Sometimes you could have multiple roles depending on certain workflow, or depending on logging in to a specific parts of the system, you may have actually multiple roles. So the attribute service, which is manipulated and managed by the administrator, can give you certain role at this point of time. So based on that, after you finish this, you have access to data consumer. Data consumer here abstracts any type of access or service that you can access using this role. Okay? So the data consumer here refers to any service, whether it's internal or external. Okay? So you can have access to different parts of the system, different services, different resources, file system, emails, things like that. ماشي. So this is the abstract system model. Identity federation here is the essence. It's an extension of identity management to multiple security domains. So you have QU security domain, and you have other security domains, which QU has certain type of agreement with these external domains. So based on that, your identity can be shared partially or fully. Okay, your attributes can be shared or mapped. Okay, so based on logging on to Authenticate, part of my identity can be shared with the Authenticate website, right? And my attributes, which is currently my role as faculty member on QU, I get a user role in Authenticate. Okay, maybe there are other types, like for example, if someone from ITS, if he tries to connect to Authenticate, they may have certain level of administration inside Authenticate within the domain of QU. So he can see all the accounts and all the users that QU and what they are using Authenticate for example. So a system admin here takes a mapped role in the other security domain. Okay. طيب. So as we said, it enabled the portability of identities, identity attributes, and entitlement. The entitlement, the certain type of access or the role that you get on each security domain, based on the agreement between these security domains. Another key function of federated identity management is the identity mapping اللي احنا بنقول عليها. So if a financial officer from QU logs on to, for example, Amazon, okay, if there is certain agreement between QU and Amazon, this finance officer may have a role of purchaser to try to buy some stuff from Amazon within certain مثلا amount of money. Okay, so the role of the finance officer has been mapped to a specific purchaser inside the domain of Amazon to buy certain equipment or to procure certain equipment. مثلا ماشي. So this is the system model for the identity federation. So here the identity provider or the attribute service, they are both built into here, and there is the user. The user first tries to claim the identity, and based on that we can specify the fact that some of his identity or all the identity information, some of the attributes or attributes to be mapped, this will be transferred from here to here. Based on that, the user will have certain type of access to that security domain or the destination domain. Okay. So in طبعا هنا the link between the administrator and the identity provider allows the administrator to verify and manipulate, in some cases, the role or the attributes of that user at any point of time within that source domain. Okay. So these are basically the steps for identification. So this is how we perform that functionality. So so there is an end user who authenticates himself or herself to the local domain, and based on that, if they want to connect from this source domain to another external service, like for example, I want to access, as I said, like Authenticate or Turnitin website from within QU domain. So my identity and user ID will be transferred. So this is what we call federation based on account linking. So we link the two accounts, so the identity information will be transferred from one domain to another. The same identity information will be transferred from one to another. And this typically happens, as I said, if we want to, for example, go to this health.com from QU, and then you say, okay, I want to sign up, okay, but using مثلا QU or using Google account. So your identity information will be transferred from that domain to that domain, and your accounts will be linked, okay?
For the password, it will stay on the service provider.
Password is another thing. Password, it can also be synchronized between the two domains. This is based on the agreement. So you can think of the password as one of the attributes having to be either synchronized, or you may have actually different passwords on the two domains depending on the agreement. Okay, as we said, there is single sign-on and reduced sign-on. QU here, they tend to actually, some of the interestingly speaking, if you try to change your password, for some external services, it gets synchronized. For other external services, it doesn't get synchronized. You don't know why. You have to try. So some services, they work right away, and some services, they require that you have to use the old password. It happened to me several times. Authenticate مثلا is not synchronized. So I either have to use the old password or I have to reset and change it to the new password. I have to do that manually. Okay. But of course, the information, the identity information, it's linked. There is also as we said, the federation based on the role, mapping the role. So, as we said, the perfect example for this is that an employee, like for example from finance, from procurement department, who has role of procurement officer in QU or finance officer in QU, he may have access to buy some parts or equipment from Amazon, for example, or from any other external website. So in that case, maybe the user ID will be shared, okay? The password, as we said, maybe yes, maybe no, and we need to map the role. So the role will be mapped from a finance officer here to a purchaser here. As we said, this is the new role that he or she gets when he logs on to this website. واضحة دي? So here, his role is purchaser. Here, his role is different. Okay? And of course, this is like a combination of the two. This example here talks about a chained web service. Chained web services here talks about the fact that the federation might happen on 2 steps or 3 steps. So for example, if an employee at QU, again from the procurement department, he logs on to Amazon, okay? So when he logs on from Amazon, he gets the role of purchaser. So this is federation based on mapping the role, right? And then from this, Amazon, they deal with multiple suppliers. So maybe through Amazon, he actually goes to a specific supplier, right, to interact with that particular supplier website. And in that case, maybe the identity will be mapped or maybe shared between Amazon and the supplier's system to, again, facilitate the procurement of this equipment. So this federation may, in fact, happen on multiple steps, not just one. واضحة دي? But again, this requires the fact that QU will have agreement with Amazon, and Amazon will have agreement to the suppliers, and you go through that, chain of services or chain of federation. Okay? So there is a standard for this called SOAP messages, if you are aware of that. It's commonly used for web services to facilitate the sharing of identity information and mapping roles and so on. Any questions? So this is when it comes to identity management and federation. Okay, so this is the summary of chapter 4. So in chapter 4, we talked about user authentication principles. We talked about the key distribution using semantic key distribution, and we went through the example of Kerberos with the detailed description of the protocol and how it works. We talked about key distribution using asymmetric encryption, including the public key certificates and the different techniques related to that. And then we talked about federation and federated identity management systems and the concepts related to that. So, all right, so let me see. Chapter 5, what is chapter 5? Yes, chapter 5. Okay. All right, so until now, we did not talk about any networking issues. So starting from here, we'll get to deeply to networks and networking issues, okay? So if you did not go through any network course, it's going to be a real problem for you starting from now. I have to warn you, okay? So you have to have like basic networking concepts fresh in your mind. If it's not, please, go and refresh your mind with some of these concepts, because we have to assume that you know all these things from now on. So we'll start to go through the TCP/IP layers. I like to always associate the security services from now on to the specific layers. Until now, we did not talk about layer-specific security services, okay? In other words, we can assume that Kerberos and all the certificates and all of this is like application layers. Like we don't have to talk about layer-specific security services per se. So starting from now, we'll go bottom up. So we'll go to network access layer. We'll talk about security services in network access layer. We'll talk about the network layer, and then we'll talk about transport layer, okay? So network access control security, and basically the objective here is that we assume that we have a workstation or a device, okay? So this device needs to have access to a physical system, okay? Physical distributed system. In network access layer, as we commonly know, it talks about the physical topology, the physical connection between devices. So when we talk about network access layer, we always talk about physical entities being connected and linked physically together. Even when we talk about wireless, okay, we assume that the air is like some kind of a physical medium that facilitates the communication. صحيح? So in a way, wireless can facilitate the physical connection between devices, device and access point, device to device, things like that. Okay? So this device needs to have access to that system. Okay? Why did I do that? Because initially, this device has to authenticate itself to the system. So it needs to first connect to an entry point to get access to that system. This happens, for example, if you have a laptop or a workstation, and let's assume that you have Ethernet cable, okay? And then you want to connect this cable to the wall. Once you connect it to the wall, you actually trigger an authentication process through a server somewhere in the physical network, okay? That authenticates the connection of this device to the physical system, okay? So during this process of authentication, I need to check multiple things. First thing is whether or not this device is actually allowed to connect to the network from this particular port or not. ماشي? So if you connect to a specific port, you trigger this process. Is that device allowed to connect to the system or not? Or in other words, is this device really owned by the organization or it's allowed through some checks or through some authentication means to access the physical parts of the system or not. Okay? That's one. Sometimes this comes with a prerequisite. Even if the device is allowed, is that device present some kind of a threat to the system or not? So how can I answer this question? I answer this question in many ways by checking that this device has up-to-date like antivirus, it has all the patches required, it has everything that allows not to be a threat to the system. So first I need to check whether it's in principle, is this device allowed to access the system or not? Second, is this device provide any threat to the system? Is it up to date? Is the antivirus up to date? Is everything is fine with this device? If the answer for these two is yes, then this control port becomes closed, okay? And now this device indeed has access, but now I have to also provide some restrictions on that access, okay? Like for example, this device, yes, has access, but based on the authentication, it has access to a specific part of the system, but not everything. ماشي كده؟ ماشي؟ So based on that, he did something. Yes, thank you. All right, so if that device is indeed allowed, if it has all the patches, if it has up-to-date antivirus and everything, then I allow it to have access to certain or all parts of the physical system. This is the objective in a nutshell that we want to achieve in this. طبعا هنا everything is like, you see the word physical, okay? Because we're talking about network access layer. Network access layer is composed of two layers. اللي هم ايه؟ Data link layer or physical layer, right? Data link layer or physical layer. Okay? As we said, I assume you have this information already. Okay? If not, you need to refresh your mind with these concepts. ماشي كده؟ So in network access layer, more often than not, we talk about physical connection, physical entity, physical devices, things like that. ماشي? So if we achieve this objective correctly, so anything that runs on this device by the user is somehow, will be allowed, okay, within the limitations that I set on the physical system for this device. So if that user tries to access any service in that domain, fine. If that user wants to go outside and hear, no. Okay? And that comes from low level, from the device, not from the user. Because this is like the physical foundation, okay, that the security provisioned to all services on this device. ماشي كده? So if a user tries to use that device to access any parts of the system, he will access it based on these boundaries, based on these limitations. ماشي? Why am I saying this? Because in network layer it will be different. In transport layer it will be different. So these are the differences when we talk about layer specific security services. ماشي؟ الصورة لخبطتني. When we talk about this particular example, this port, by the way, we talk about physical port, but it could also be a logical port if we talk about wireless. If we talk about wireless, we sometimes call this a logical port. Whether it's a physical port or a logical port, remember, this is different from the transport layer port. Huh? The port in TCP level, it identifies what? Port in TCP layer identifies what? Identifies a service or application. Bravo عليك. Yes. لا, here port, we talk about physical port. Physical port, it connects a device. ماشي؟ الثاني البورت اللي هو part of the TCP header ده, it's used to identify a service or an application. That's totally different. يعني برضو just making sure you're not confused between these two. طيب, so this is in a nutshell. يعني how can we do this بقى? We'll talk about the details. So network access control here talks about the umbrella term of managing access to the network. اللي هي physical system أو يعني we have distributed system which is composed of like some physical devices physically connected with each other. ماشي؟ It authenticates users logging through a device, okay? So if the user logs in through a device, لو logs in on the operating system, this user will have access based on the port authentication for that device and the limitations that we give to that device being able to access different parts of the network. ماشي? Also examines the health of the user's computer and mobile device. ماشي؟ طبعا this when we talk about this particular example, we can oh okay yeah. طيب, so some terminology بقى in that regard. So we have network access control systems deal with these three categories of components. In abstract level, we have access requester. The access requester is the device or the user on the device who requests access to the network. ماشي? Node that attempts to access the network and maybe any device that is managed by the network access control system, including workstation, server, printers, cameras, anything. Mobile device, IP camera, anything. ماشي كده? We also refer to this as supplicant. يعني again, يعني the terminology keeps changing from now and then, so pay attention to that. So here, whether it's supplicant or access requester, they refer to the same thing. And there is the network access server. Network access server, this is the entry point we talked about. So this network access server is the entry point that provides the authentication to the connection through which you have access to the network. So it functions as an access control point for users in remote locations, also called the media gateway or the remote access server. So these are names for the same thing. It may include its own authentication services or rely on separate authentication. We'll talk about this. So the network access server, it may have its own authentication protocol or authentication service that authenticates a port. It may in fact rely on other external systems, okay, to facilitate that authentication. And we'll talk about both options. The policy server بقى, policy server is slightly different. Policy server, it determines what access should we grant. So after we answer the question of, yes, the user is authenticated, but now the policy server specifies which part of the system that this device can access. So the boundaries may be specified, for example, by a range of physical address or a physical LAN, okay? A certain subnet, which is defined by what? IP addresses, صح? Or a range of IP addresses, or a certain virtual LAN, which is somewhere in between IP and physical LANs, right? So it may actually span through multiple LANs, and we logically group these LANs together. We'll talk about this more. ماشي كده? So these are the three basic technologies to do that. So this is again the system model. So for everything, we have first and foremost we talk about the system model of the entire system. That gives you like some picture, the overall picture of how this works. So we start with the supplicant, which could be like a laptop, workstation, cell phone, anything. And this connects to the network through the entry point. So this is the authentication server, which might be a wireless access point or a switch, right? An Ethernet switch. Once you connect physically to a specific port, the switch will perform that authentication. So this authentication server will authenticate the port. Once it's authenticated, it goes to the policy server to kind of make sure that all patches are fine, antiviruses are up to date, things like that. And then this policy server will use some servers to provide certain boundaries. These boundaries, DHCP servers are used to assign IP address. So through the DHCP server, we can specify certain range of IP addresses based on which this device will not go outside it, or virtual LAN server, which you know what the virtual LAN is used for, right? So, yani, if we can do that from a topology perspective, so you have a switch which has multiple physical nodes, okay, and you have another switch which has multiple physical nodes, okay, and maybe here you have a router, and this router has different router ports to these physical LANs, right? So this a user comes here, or a device comes here, and this device wants to connect to the switch, right? So this connection to the switch will trigger the authentication. So first, this port will be open like this, okay? And then the switch will have to authenticate that device. Authenticate that device, meaning that it triggers the authentication process, and we'll see it's a full protocol. You have to do handshaking, you have to send messages back and forth, and these messages will use physical addresses of that machine to facilitate the authentication and so on. And after this, it closes that port and it makes it valid. Once the port is validated, then the policy server will say, okay, so based on this port authentication, I will give you access to this physical domain. So the policy server specifies the physical addresses of all these nodes, okay? Which means that you have access only to the physical LAN that you exist in. Or I can give you access to these two LANs, which means I can have a range of IP addresses of all these two LANs, okay? And I provide this at the policy server to say, okay, so this particular device will have access to all this range of IP addresses. Or, you know, the virtual LAN is like you group مثلا 2 from here and 2 from here, and then you form like some kind of a logical ports. So these are virtual LAN is like group of ports which can span multiple physical LANs, and these are grouped logically together to form what we call a virtual LAN. You probably heard that term before, so we did not study it in details in Network 1 at least, but we study it roughly, okay? So these are group of ports that are logically grouped together to form a virtual LAN. So physically they are separate, but logically they are one group. ماشي كده؟ So based on whatever boundaries and restrictions that the policy server will provide to that device, the communication can be restricted to a certain type of boundary. ماشي كده؟ What, any questions? Any? So as we said, the policy server may, in fact, and the network access server may, in fact, use some other external servers to facilitate, for example, the health checks on antivirus, on patch servers, on a range of IP addresses, on the boundaries, and so on and so forth. And once all these checks are done, then this supplicant or this device can now have access to all the network resources based on the policy that is provided to it. So the part on the left-hand side represents all the available nodes in the network that can be accessed through that port. ماشي كده؟ So it happens, I'm not sure if it happens to you or not, it happens many times that you connect a certain device to a port, you try to communicate, and you have access to a specific subnet. But if you try to connect to other subnets in the network, you're not allowed to do that. Unless you use certain ports like port 80 or port 443 or something like this. So these are the restrictions we're talking about. So the policy server may, in fact, policy server can be actually connected to a firewall canal. So it can provide these restrictions on multiple levels. So network access enforcement here talks about the actions of that is applied to the access requesters to regulate access to the enterprise network. This is what we are talking about. So many vendors support multiple enforcement methods simultaneously. So it can be provided simultaneously, allowing the customer to tailor the configuration by using one or a combination of these methods. So it can be, again, as we said, can be physical address level, can be logical address level, or IP level, can be based on virtual LANs, can be based even on specific ports, transport layer ports. It can be, it can include, in fact, certain types of services, whether HTTP service, مثلا, or things like that. ماشي? طيب. So there are certain protocols, and we'll cover this and we'll talk about the rest next time. So as we said, we have multiple servers, whether it's a virtual LAN server or a firewall or DHCP server, which manages the physical addresses or logical addresses or IP addresses based on which we can provide these enforcement or these restrictions. This is about the most important protocol that we'll talk about probably next time in more details. It's called the 802.1x. And this is the one that's used to provide the process of authentication for the port. ماشي? We call this extensible access protocol over LANs. ماشي? We'll talk about the details of this protocol next time. So this provides a layer above the data link layer to facilitate the process of authentication to that port. Okay, so this protocol is used to exchange some messages for the authentication of this device with the network access server and possibly to external servers as well. And this communication or this handshaking will go back and forth until the port is validated and controlled. And once the port is validated, then we can start to access the network. So we'll talk about this layered model next time because it involves some details. So this is the extensible access protocol over LAN, authentication protocol over LAN. So we'll talk about each of these layers and how it works and what messages are exchanged between the device, depending on the type of the device, whether the device wants to connect through an Ethernet port, wireless port, or even point-to-point protocol. We'll talk about the differences between all of this. Any questions? Any questions? No questions mean it's negative, by the way. This means that you're not following or something like this. Or maybe it's okay يعني. هو كلام نظري شوية بس. ماشي.